recording. So for your warm-up today, you didn't necessarily need to write this down, but you need to know how to get it. You need to know how to get the answer. So what do I know about these? What are... Okay, R and Q. So angle R plus angle Q add up to what? That angle P right there. Now, what is this called? This is called the remote interior angle theorem. So these are your remote interior angles to that corresponding exterior angle. So if I add these together, do you agree with me that I get 7x plus 31 equals 8x plus 17? Okay. I'm going to move 7x to the other side and move 17 to the other side. What is 31 minus 17? 14? And what's 8x minus 7x? X. So, therefore, I now have x, but is that what my question's asking me?
No, solve x.
No. Oh, Alexandra. You're leaving. But not till 2.
Bye.
So you can watch this too. Alright. I need to solve for x, so we did that, but I also need to classify this triangle. In order to classify this triangle, what am I going to need to know? What all the angles are. So I'm going to plug in. What's 3 times 14?
42.
Plus 19?
51.
So that side is 61 degrees. What's 4 times 14?
56.
Plus 12?
68.
So if I know this is 68 and this is 61, how do I find this angle right here? Add them together and then subtract from 180. So I get 129. 180 minus 129 is? 51. What type of triangle is this? They are all acute, so it's an acute scalene. Why is it scalene? They are all different. Do I have any questions about that?
When it just says classify the triangle,
Do both. Yeah, if it just says classify, do both. Sometimes I will say classify by side or angle, then you only do one. All right. Yes. Yes. Okay. Which of the numbered angles at the right of this picture are exterior angles? So which angles are exterior? Angle 5 is exterior. What else? Angle 6 is exterior. 8 is exterior. Is 7 an exterior angle? Okay, remember, exterior angles have to be linear pairs with my interior angles. So what are my interior angles? 1, 2, and 3. Angle 7 is not a linear pair with 3. What is it? So it's not. What about angle 4? It's just a straight angle. It's not really anything. So, all right. That's all I wanted y'all to know on that one. Okay. Did y'all start a page for isosceles and equilateral? Okay, so I will tell you what to write. But today we're going to be focusing on both isosceles and equilateral triangles. Isosceles, just to break it down, means the same leg. Equilateral means equal sides. So I know we've already talked about what these two things are. We're going to go a little bit more in depth with them. Okay? So I would like you to please, and you're going to take up, we're only going to need like 5 lines for equilateral, and then we're going to do 3 examples with isosceles along with the notes. Okay? So for isosceles, if you could please draw this triangle and label it as so. So an isosceles triangle, it's a triangle. It has 3 angles. And it has 2 sides that are congruent. Those 2 sides that are congruent, we call the legs. The 2 sides that are congruent, we call the legs. Across from them, the isosceles triangle theorem states that if you have two sides congruent, then what? My two angles across from the two sides that are congruent are also congruent. So this angle, do you see how here's a side? Across from that is angle 3, is going to be congruent to which angle? To angle 2. That is the isosceles triangle theorem. And we'll talk about that. Right. So if you have two sides congruent, you have two angles congruent, and those two angles are called my base angles. So what do you think the side is that the two angles connect with? What do you think that's called?
The base.
The base. Now be careful. Your base is not always going to be on the bottom. Can an isosceles triangle still be isosceles but turned upside down?
Yes.
Yeah, so just be aware that your base is not necessarily on the bottom. Last but not least, if we have two angles that are congruent, don't we have one angle that's chilling on its own?
Yes.
That angle is called the vertex angle. And that vertex angle is always going to be in between the two legs. Yes. All right. Can I change it? Okay, you don't need to write the next things down. You can just need to look up here. So these are some ways that I might ask you about them. I might say if TR and RI are the legs, TR and RI are the legs, that means they're congruent. Then what are my base angles? Angle T would be congruent to angle I. Does that make sense? What would be my vertex angle? Angle R. And what would be my base? TI. Does that make sense? Okay, now over here, I have triangle ANG. If angle A is an angle N are base angles, what do we know about these two angles? They're congruent. And then so, what are my legs? And please make sure when you write these, they are segments. So AG would be congruent to NG. Does that make sense? Any questions? All right, this is just, again, stating my isosceles triangle theorem. You don't need to write it down. But if two sides of a triangle are congruent, then the opposite angles are also congruent. Okay? Now, the converse is also true. What's converse mean? Opposite. So if two angles are congruent, what does that tell me? The opposite sides are congruent. Okay? Alright, so I'm going to draw a picture over here. I was supposed to have pictures here, but it didn't necessarily work out. So, let's see. I'm going to draw these pictures so it ends up in my... Okay, no, I'm not. Alright, if I have ABC, so if I have triangle ABC, and AB is congruent to AC. If I tell you AB is congruent to AC, what do I know?
Then AB is a leg, and AC is a leg.
They're a leg, but what else do I know?
It's an isosceles triangle.
Okay, besides it's an isosceles triangle.
That the angles of the
Which ones?
that
A would be the vertex. B and C are the base angles, therefore they are angle B is congruent angles. Okay? So, and I can always flip that around, make it any way I want. Alright. So we're going to do some popcorn. And we're not making popcorn, no. I need a volunteer. Alright, cool. Nicole, can you name this triangle? Not classify, but name it. This would be triangle what? Name it. How would you, if you were to, that's classifying it. So classifying is isosceles. What is its name? It's triangle BAT. Okay? Cool. Nicole, choose somebody else in the class. Who did you choose? Ramses? Okay, Ramses, what are my legs of this triangle? Okay, are they lines?
It's a segment.
But otherwise perfect. Don't forget when you're labeling this to put the segment above. BA and what'd you say? TA. Is that the only way he could have said this? No. Could he have said AB and AT?
Yeah.
It does not matter which way. All right, Ramses, choose somebody.
Yeah.
Talon, can you tell me the base? Word before that. Otherwise, you're good. Segment BT. Good job. Did he have to say BT?
No.
He could have said TB. Could he say anything else besides those two, though? No. All right, Talon, give me somebody else. Lily. What is the vertex angle here? Give me a word before that.
Angle.
You have to put the angle symbol, and it's angle A. Perfect. All right, Lily, choose somebody to tell me the base angles.
Grace.
All right, Grace, what are my base angles here?
Angle B and angle T.
Angle B and angle T. Perfect. All right. And Grace, choose somebody. Carolina, which angle is opposite AB? So which angle is opposite line A or segment AB? Give me a letter.
T.
Angle T. Angle T is opposite of segment AB. Perfect. Carolina, can you choose somebody else? What's his name? Griffin. All right, Griffin. Which side is opposite angle A? Segment BT. Here's angle A. Opposite of that is segment BT. All right, Griffin. Before Griffin chooses somebody, think about it. Anybody, which side is included between B and T? So this one was really weird because I thought it was a weird question. Which side is in between or between B and T? It's just side BT. Yeah, that's why I didn't want anybody to answer it because it was a weird question. I would never ask that, so I don't know why. Okay, Griffin, who'd you decide? Krish. Which angle is between BT and BA? So BT, BA is angle B. Perfect. And Krish, can you choose somebody? Scholar. If angle T is 23 degrees, then what is angle B? 23 degrees. And Scholar, while you think about the answer, I want everybody else to actually calculate. What is angle A? When you think about who you're choosing, Scholar, do you know who your victim's going to be? Who? Jonathan. What is angle A? Or do you want us to walk through, if you haven't calculated it yet, walk me through how you figure out angle A. Okay, so 23 plus 23 is? And then is that my answer? What do you do? 180 minus 46 gave us 134 degrees. Don't forget degrees. All right, and Jonathan, the last victim of right now? Scott. All right, Scott. I'm actually not going to have you solve this out or anything, but looking at this, if I tell you BA is 3 times 2x plus 4, and I tell you AT is 2 times x plus 4, what are you going to need to do to find x? What would you do? Make them equal to each other. And then I'm actually not going to take time right now to solve that out, but are y'all all okay with this process? Do I have any questions about any answers that one of these lovely people have answered? It's because they're equal to each other. So they're congruent. Yep, exactly. All right. So we're going to do 3 examples. If you could please draw this first example as example number 1. All right. What do I know?
Isosceles triangles all over the place.
There's a bunch of things congruent to each other. So remember that number 2 rule of geometry I told you about a long time ago? That was number 1. Number 1 was don't assume. Number 2, when in doubt, make a triangle. And you're probably like, Ms. Alvarez, this is a triangle. But you can make smaller triangles. So I encourage you to break this up and look at this triangle. Do you agree that it is isosceles?
Yeah.
And since it's isosceles, what do I know? If this is 22, then V equals 22. So V equals W equals X, Y, Z. So what is V?
22 degrees.
22 degrees. So if I know V is 22 degrees, how would I find W? 22 plus 22 is 44. Subtracted from 180 is what?
130.
Oh, man. 136?
Yeah.
So W is 136 degrees. Now, how would I find X? They're a linear pair. 180 minus... Or... Can't you do the remote interior angles? What's 22 plus 22?
44.
Either way, you get the same answer. So X is 44 degrees. Now that I know X, what else do I know? Do I know Y? No, that's the vertex angle. But I know these 2 sides are congruent. Let me do a different color now. So since I know those 2 sides are congruent, right here and right here, don't I know these 2 angles are congruent? And so if this is also 44, what is Z? Whoa. Z. Z, not Y. Y'all, Z.
136.
Z.
136.
Because they're a linear pair. Y'all, I wasn't asking for Y yet. Now, how do we find Y? 44 plus 44 is... And then that's how y'all got 92. A lot of people kept saying it, but I think they thought I was asking for Y. Do I have any questions about that? Do you see how you need to break it up into smaller triangles to figure things out? All right, are you ready for example 2? Again, you don't have to write this up here. Draw the picture and label the appropriate sides. I'm glad. Okay. What do I know? What do I have here? I have a 90 degrees and I have isosceles. So what do I know about these 2 angles here? A and C are going to be congruent because they're opposite my congruent sides. So can I set up an equation? Now we have a problem. What is our problem? There's X's and Y's. Don't panic yet. Don't panic yet, because if I have X's and Y's, then I need another equation. There is a 90-degree angle, and what do I know about all of these angles? They all equal 180. So can I say 90 plus x plus y plus 4x minus y equals what? And sometimes, not often, but sometimes I'm really nice. How come I'm really nice? Before we get there.
It's XY thing.
What's y minus y? Oh, aren't we doing a pretty thing for you right now?
Thank you. I appreciate
No.
it.
I thought so. Not always, but for right now it will be. Hint, hint.
Enjoying it.
Hint, hint. How do I get x by itself?
Subtract 90.
And what does x equal?
18.
Cool. Did I answer my question?
No,
I solved for x, so I answered that question. How do I solve for y? Go plug in x. I know it. Look, I got my nails done finally, so at least this video has pretty nails. I'm going to plug in my x's. And that gives me, what is 4 times 18? I mean, why did I write 14? 72 minus y. How would I get y by itself?
We don't have to write all of that on the actual thing, right?
I mean, you have to solve it out.
No, I mean like we don't have to put every single step, right?
So let me tell you about that in a second. What's 72 minus 18?
54.
Divide by 2, and what does y equal? Good job. Okay, so Elsie pointed out something really good. She said, Miss Olivares, it's isosceles and it's 90, so don't I know that this is 45 and 45? Yes. However, if you were to say x plus y equals 45, would that solve all this out for you? No. So you could go that way. You would just have to do substitution and do a lot more work than what this happened. But it would still give you the same answer, Elsie. Yes. A lot more work possible in that way. All right, we have one last question, and then we're going to talk about equilateral, and then we're done. Okay? Last one. I particularly like this one a lot. Find x, y, and z, and then classify. Go.
Oh, okay.
All right, so what was the first equation you got?
2y plus 2 plus 20.
Okay, so you could get my x's would be 12x minus 22 equals 9x plus 23. And then I heard somebody say the y's, they got what? Oh, wait, I meant the equation.
2y plus 26 equals 7y minus 4.
All right. So I'm just going to real quick silently solve these as y'all finish up what you're doing. Look up when you're done. This one was fun. That's the second time somebody said fun in my class today. I'm going to take it as...
I just like knowing what I'm doing.
All right, what's 45 divided by 3?
15.
So x is 15. Cool. And for y?
7y
So y equals 6. But are we done?
No.
We need to find z. How do we find z? Okay, plug in my y for 6. So what's 7 times 6?
42.
Minus 4 is 38. And so what should this side be?
38.
And if I were to plug that in again, I would get 38. So if I get 38 and 38, how do I find z?
Subtract it.
So 180 minus 76 gives me what? 104 degrees is z.
I would have got that by an angle of 6.
Okay. That was the longest. All right. Are y'all ready? Maybe your mind will be blown a little bit, maybe not. But I got to show you 3 more things, and then I'm done, and you're doing homework. We can construct an isosceles triangle. So listen carefully. I am not going to actually physically have you construct an isosceles triangle on your test. However, you may have a test question about it. So watch. If I have a point here, oops, okay, I'm going to make an angle. Are y'all okay with that? And then I'm going, is that an angle? Okay. I'm going to take my compass. It doesn't really matter how far I open it, but I'm going to open it about this far. And I'm going to put my stylus on the vertex of the angle, and then I'm going to draw an arc. Oh, wow, that was really bad. Let me do that. I'm not left-handed, so that didn't work out too hot. Okay, I'm going to draw an arc. Okay? Still really bad, but we'll just ignore that. Here's where my arc intersects. Here was where my arc intersects. Hey, guess what? If I connect them, that side is connected to that side. If I were to measure them, they would be the same. Here to here. Here to here. Oh, that one didn't work out too well. We'll have to fix that. Let me do another example. So, let me draw an angle. There we go. Let's see if I can draw the arc right this time. Oh, yeah. Sorry. Okay, if I draw my arc. Thanks. I'm going to draw an arc. There we go. I'm getting it. I drew my arc. Where they intersect. I connect. And then, bam, bam. Those two sides, if I were to use a ruler or measure, they would be exactly the same. Okay? Now, are you ready for your mind to be blown a little bit more?
No.
A little bit. Just a little bit, okay? Equilateral triangles. What's the definition of an equilateral triangle? If a triangle is equilateral, then it is equal angular. So you can write this down if you don't need to. But an equilateral triangle, all sides are the same, and all angles are also, what do my angles have to be then? 60 degrees. Okay, here's the thing people mess up about equilateral triangles. Actually, mess up about all triangles. Guys, if my angles add up to 180, what do your sides have to add up to?
Each other?
Wait, can you repeat the question?
Angle in a triangle, angles add up to 180. What do your sides add up to?
90?
It doesn't add up to anything. It doesn't matter. You can have different perimeters, can't you? Yeah. But the thing is a lot of times, y'all tell me, your sides have to add up to 182. That is not true. Okay? It doesn't have to work. I could have each side right here could be 2. What's 2 plus 2 plus 2? Your perimeter could be 6, and that's fine. I just want you to emphasize that because sometimes what I'll get is I will give you all the sides. Like I might tell you this is 2x, 3x and whatever, and y'all are going to tell me all of those add up to 180. They don't. Your sides are different. All right. I'll show you an example in a little bit. Can I change this? All right. If all my sides are congruent, then all my angles are. The converse is also true. If a triangle is equal angular, this is the converse, then it is equilateral. So if all my angles are congruent, then what can I conclude? All the sides are congruent. All right, so you ready for your mind to be blown a little bit? Okay, just a little bit, okay? If I have to construct an equilateral triangle, I'm going to have a point, and in my point, I'm going to use the compass, and I'm going to make a circle, okay? So tell me if I go off the page for y'all, but So now we have a circle. Can y'all see that? Okay. Now, I am going to choose a point. Do you agree that this is my radius?
Yes.
Okay? Because I went from the center to a point and I have a radius. Now what I'm going to do is that point, I'm going to put my stylus on that point and do the same thing we just did. I'm going to do another circle. So, what does that now tell me about my circle?
It's gonna be a triangle now.
I'm creating a Venn diagram. Oh, it kind of went off, but we're going to pretend it didn't go off. It went off right there. All right. I created another circle, and do you agree that these circles have the same radius? Is everybody looking up?
Yeah.
Do you agree my circles have the same radius?
Yeah.
So do you agree this point where they meet right here is also the radius? And this point right here, if I connect it to that, is also the radius? What did I just create? An equilateral triangle. And that is how you construct an equilateral triangle. Am I going to make you do that? No. But am I going to have maybe a problem or a question that shows what this is doing and ask you what the process is happening? Okay, you have the rest of the class period to complete the homework that Lily's going to pass out to you. Before she does that, I need you all to look up here because I want to help you out with a problem. Look up. Problem 9. Everybody asked me about problem 9 last period. It tells you that ABCDE is a regular pentagon. What does that mean if it's a regular pentagon? Remember, regular means all the same sides, and so that means this side is congruent to this side. If those two sides are congruent, don't you have an isosceles triangle?
Oh my God.
And if you know that angle is 108, can you find these little sides? How?
You divide by subtract 180 minus that, and then you divide by 2.
Subtract from 180, so 180 minus 108 is 72. That my answer?
No.
Divide by 2, so what is my answer for y? 36 degrees. Now, hold on. If that's 36, what's this? Where else is 36?
On the other side.
This is the same triangle because remember, they're equal angular. That's 108. And again, those are sides. So these are all 36 too. What is this whole angle D? Angle D is also 108 degrees. So that purple thing, that purple arc, that is all 108. If you know this is 36 and this is 36, how do you find x? Not 180. What's your angle? 108. Okay, so that is what you are going to do on that problem. Thanks for watching. Bye.